All right, nerds. So what we're looking at is, when we look in chemistry, we're looking at changes, basically. But there are two types of changes. There are physical changes and there are chemical changes. And we want to be able to tell the difference between the both. Okay. So, we'll go back there while we load our pen up. Okay, let's roll. So, changes. Here we have a pile of changes. These are the ones we're going to look at, and they're changes that you'll see, not every day, because not every day is a firework day, but you'll see them in your life. So in physics, we deal with three types of changes. There's physical change, chemical change, nuclear change. We're not going to talk about nuclear change yet. We will, but not right now. So what we want to talk about is we want to talk about this with relation to the law of conservation, okay, of matter or mass, which means whatever we have on one side, they can be rearranged all they want. So whatever we have on one side of a reaction or a change, they has to be there on the other. It can be rearranged, but it's still there. All right, so a physical change and a chemical change. This is essentially going to be broken up as a table. If we wanted, you could draw it down here, and that might make your life easier when you're writing about this. Okay, so physical properties. So in a physical change, the physical properties usually don't change. Sometimes they can, but they usually don't. They are reversible, and that's really important. That's the key. And the real thing that makes it a physical change is no new substance is formed. All right. Example of that is, go back. Example of that is ice. Okay, when we change water to ice, it's still water. It's just solid frozen water. Okay, so that's no big deal. That makes perfect sense. Okay, it's still usually the same color. The properties are roughly the same. We're good. No new substance is formed. Chemical change. The physical properties do change. Always have to change. So do the chemical properties. It's irreversible. It doesn't go back. So while we're talking here, the physical properties might be the same. They might possibly change. In a physical change. The chemical properties are identical. They do not change. And most importantly, a new substance is formed because the atoms have been rearranged. Alrighty, so here we have water. Okay, so here's water, that's the oxygen, there's two hydrogens. When we make hydrogen peroxide with water, we now have a rearrangement of atoms. We have two oxygens together with two hydrogens. You can even see that the molecules are different shape. That is a chemical change. A new substance has formed. So all these changes involve energy, but a chemical change usually involves a lot more. Okay, so let's look at these ones. Let's break them down. Boiling water. That one there is a physical change because it turns into steam, but it's still water. Fresh lemonade, physical change. And the reason it's a physical change is because it's a mixture. You can just... You put it in there, and if you were to dehydrate it or just let it evaporate, you would all have all the sugars and stuff. They would still be there. Baking a cake. It is a chemical change. You are making new substances. You are breaking chemicals down and creating new substances. And you do that through the input of a lot of energy. Digesting food. It's the chemical reaction that keeps you alive, one of the two. There's that, and then there's respiration, which is what you do with that food afterwards. So when you digest food, you are literally digesting, means to break apart. You are breaking apart the chemicals inside that food. That's a chemical reaction. Fireworks, color change. That's a chemical reaction. When you eat food, you get warmer on the inside, by the way. So fireworks is a chemical change. Mowing the lawn, still grass. It's grass that's in much smaller pieces than it was before, but it's still grass, so it's a physical change. All right, I hope that made sense. Do the form, bring in your questions, you'll be golden.